So under soil, the first test we're going to look at is moisture content determination. What is moisture content? Moisture content is the amount of water present in a soil expressed as a percentage of the mass of dry soil. What is the objective of this particular test? The objective is for us to be able to know or to determine the amount of water present in a soil expressed as a percentage of the mass of dry soil. So what are the main principles? The moisture content of a soil is assumed to be the amount of water within the pore space between the soil grains, which is removable by oven drying at a temperature not exceeding 110 degrees Celsius. As we know, the moisture content has a profound effect on soil behavior. We'll come to learn more of that when we learn of linear shrinkage test, where we'll come to realize that soil in the presence of water expands. When that water is removed, it shrinks. And so if you use, for instance, a soil with a high water content, let's say in road construction, once that water evaporates, what remains? Voids. Eventually, the bituminous road weakens and cracks begin to develop. That's food for another day. So, for this particular test, what are the required equipment? Mind you, moisture content determination is one of the tests with the shortest test procedure. So required equipment, you only need, number one, a drying oven with temperature ranging from between 105 degrees Celsius to 110 degrees Celsius. Number two, a balance readable to 0.1 grams. Number three, a metal container. Number four, a desiccator. Test procedure. Step number one, clean and dry the container. Then weigh it to the nearest 0.1 grams. That will give you M1, meaning the first mass. Step 2. A representative sample shall be crumbled and loosely placed in the container. Now, there are three categories of this representative sample. First category, for fine-grained soils, the sample weight shall be minimum 30 grams. For medium-grained soils, the sample weight shall be minimum 300 grams. For coarse-grained soils, the sample weight shall be minimum 3,000 grams or 3 kgs. So just know 30, 300, 3,000. Leading us to step number 3. So now on step number 3, the container with the sample inside shall immediately be weighed, and that will give you M2, which is mass number 2. After the mass has been recorded, place the container with the sample inside in the oven to dry at temperatures ranging from 105 to 110 degrees Celsius for a minimum of 12 hours. Step number 4. After drying, remove the container and sample from the oven. Leave it to cool. After it has cooled down, you weigh the container with the dry sample inside, or the dried sample inside. That will give you M3. So for moisture content determination, you only need 3 masses. You only need 3 masses: M1, M2, and M3. And then you go ahead with the calculations. So I'll write the formula for moisture content determination on the plain paper. Okay, it is not turning, so I'll just do this. Okay, so you have W is equal to M2 minus M3 divided by M3 minus M1. All this shall be multiplied by 100%, where M1 is the mass of the container in grams, M2 is the mass of the container and wet soil, 3 is the mass of the container and dry soil, equally in grams. So the value for moisture content, okay, is recorded in percentages. And the final moisture content is reported to 2 significant figures. The final moisture content is reported to 2 significant figures.